Oh, I don't remember. I do not remember exactly what we have done with this yet. But what is an inequality? Equations tell you things that are equal. Inequalities actually tell you things that are not equal. And we have our beloved inequality signs, which hopefully you have mastered by your 7th grade year. You have the greater than sign. You have the less than sign. We do have the equal sign. I'll just put that down there because it's one of those. Even though it's not really an inequality, that's why it's doing that. But don't forget, we have a couple other ones stuck in the middle of there. You have the greater than sign with a half equal sign under it. That means it's greater than or equal to. And you have the less than or equal to sign. And when we do these, a lot of times they will ask you to, because if I gave you this, if I said x is greater than 6, what would be the answers for x? Numbers that are greater than 6, Riley, would be
Everything above 6.
everything above 6. And it's kind of hard to give all those answers if I asked you to rattle them all off. So when we graph these, we use a number line. Okay? And we know this number line starts at 6, but it doesn't equal 6. And the way I show something starting at 6 but not equaling 6 is I put an open circle there. If it's a closed circle, it means it does equal it. If it's an open circle, it means it starts there but doesn't equal that. And it's greater than. Numbers that are greater than 6 go this way, so you darken in a nice dark arrow. Have you done this year? Or no? I didn't catch. Did anybody actually say something? Okay. And a helpful little hint for you to know if you put the arrow on the right way, on the right side, is you see this thing here? Look at this and this. They are the same symbol. Arrow there, the point's there. Or if you had this, x is less than or equal to -2, if I'm graphing that, this time, because it's an equal sign there, you're going to put a solid dot there. Because 2 could be the answer to that. It equals 2 and it's less than. What side are the numbers less than -2 on? Left or right? Somebody? Left. All these over here are the numbers where they get smaller, so you would color in, darken in, and put the arrow. Please understand, at the bare minimum, you need to have that -2 there. Too often I see people graph things that look like this. They get they get x is greater than 8, and then they do this for their graph. And I'm like, I have no idea where that starts or whatever. You have to at least put the 8 there and darken in this side of it. Don't do the minimum, do the maximum, that sort of thing. Now, unfortunately, oh boy, this stuff gets a whole lot more complicated. Yay for you. Because we're going to have to solve some inequalities. I'm trying to walk you through this as best I can. There are some complicated things, and this is why you should always go back to your notes and look and see some stuff here, because there's going to be some things here that are a little goofy. If I have 3x plus 1 is less than or equal to 7, the notes are going to say solve and graph. Solve and graph. Well, to solve, you do it just like an equation. Just like equations. Which would mean if I was solving this for the letter x, what would be the first thing I would do? If I want to get the letter x by itself, I got to get rid of the 1, got to get rid of the 3. First thing I would do, Brianna is, I would not get rid of the 3 first. I'd get rid of the Get rid of the 1 first. You do the multiplication division part last. So you subtract 1 from both sides. That's our equation business there. It goes away, and now I have 3x is less than or equal to 6. And then if that were an equation, the next thing I would do is, Janet Dervis, do what with the 3? Divide by 3, divide by 3. So x is less than or equal to 2. I've solved it just like an equation. Graphing it would look like this. At 2, it is a solid dot because it equals, and it is less than, so it goes this way. Somehow that didn't seem to be as solid as I was hoping for. Let me give you another one. 6x plus 1 is greater than or equal to negative 5. 6x plus 1 is greater than or equal to negative 5. Solve and graph. Jaden Schutz, first thing I would do is subtract the 1 to get rid of it, do it from both sides. I'm left with a 6x and my greater than or equal to sign. What is negative 5 put with a negative 1? Tough one there. Elijah? Negative 6. Okay. Now, Brooklyn, what do I do next?
You will divide by 3.
There's no 3s there.
6.
How about a 6? Yeah, we want x by itself, so 6 divided by 6 goes away. Negative 6 divided by 6 is negative 1. When I graph it, then I get, at 1, is it going to be closed, circle, or open? Why closed? So there's an equal sign there. And which way am I going to draw the arrow, to the right or to the left? Her? Her? This thing goes this way, like this thing goes this way. X is greater than goes to the right. Thank you very much. Now, a couple special cases here, children. Take a look-see at this. Do not neglect to write down this example. In equalities, the x has to be on the left side. If you run across this, okay, if you run across this, you can still solve it for x. What would I do to solve that for x? Manny? What's by the x that you don't want? How do I get rid of the plus 3? I subtract 3. So I subtract my 3. I subtract my 3. I get 4. This, ladies and gentlemen, is not acceptable as an answer. There's an easy fix, but you can't leave it like that. It says 4 is less than or equal to x. We want the x to be first. So I can flip them around. I can flip them around, except if I flip them around, I've also got to flip the sign around. Okay? And it makes sense because, look at Mr. Alligator, as you were taught back in whatever grade, is eating the bigger one. Just because I move the x over here doesn't make it smaller. It just changes its spot. So Mr. Alligator is still going to eat the bigger one, which is still the x. If you flip-flop places with this, then the sign has to change to its opposite as well. Okay? Get that in your head there. It has to rotate there. Okay, and then when you graph this, it would look like this for, I'm going to try and see again with Elijah. Elijah, what side am I going to shade in on that one? There you go. You are right on that one. Okay, so that's case number 1. The other case is, maybe do they give it to me? Maybe they don't. Maybe I don't have to worry about this other one. Okay, no, I'm not going to worry about it. We'll come to that. We'll cross that bridge when we come to it. Alright. So let me give you actually one here. Let me just give you one, we'll see if it's okay. 3 is greater than or equal to 2x minus 5. 3 is greater than or equal to 2x minus 5. Graph and solve, or solve and graph actually, the order. Graph and solve that for me downstairs. Graph and solve. Graph and solve. Graph and solve. See if you get the answer that I get based on past examples and your rules. So much. This is what I have used. Look at your notes. Look at the notes. This is all right. All the notes are on this one. Is this not inside here? But these notes we just took right now. You already have these notes in the file. Oh, so when you come up and ask me, you don't understand this, and I'm going to say, show me your notes, you're going to say, I decided not to take notes because I thought this was more important. I just don't think that was a wise decision. I mean, I would think I'd wait till at the end when I'm talking, and then it'd be a good time, and then I haven't missed, so maybe when I got that. We get an answer? Here's how what in yours should look like. First of all, you solve for x, right? Luke Franklin? What'd you get? Tell me what you got for an answer.
4.
Well, you can't really have 4 because there's an inequality sign there. So it's either going to be x is greater than, less than, equal to something for.
X is less than greater than.
No, it can't be less than or greater than.
Less than
Or equal to.
or equal to
X is less than or equal to what? 4. Well, let's check and see. So you should have added 5 to this, right? Added 5 to this, you get 8. Divide by 2 to get x by itself, divide by 2 to get x by itself. I do get a 4 there. And then I rotate places and I rotate change signs, so x should be less than or equal to 4. You are correct, sir. So at 4 it is a colored in circle, because it's equal to, and it goes this way. Everybody's pretty much good with that. Stop me now if you didn't catch that or ask me why. It's not really rocket science, but that's like, I love the awkward silence as well, that's always good.